suppose, for example, that you're doing a study on American industry. Well, we've got some industries, like the automobile industry, where the firms are huge. Because the auto companies no longer make their own parts, and they no longer distribute their parts to dealerships and so on and so forth, if you added together all the people that are directly affected by the automobile industry, it's something like 1 million jobs. Those 1 million people aren't all employed by Ford, Chrysler, and GM. It's the local parts distributor, it's the local auto repair guy, it's the local car dealership, and so on and so forth. And so it's a huge industry, and the automobile companies themselves are huge. On the other hand, we've also got firms in our data that look like the street vendors here in Tomaine Alley at Temple. And so when there's an economic event that causes a response by the firm, whether it's one of these little street vendors or GM, or the automobile industry, we would expect that the variance of the response in the automobile industry would be much bigger than the variance of the response amongst the food vending truck firms. So that's a heterosked case, because your data is, your cross-section is so disparate. Qualitatively, they're quite different animals.
How do we apply this randomly?
Oh, good question. A couple of people over the last couple of weeks have sent me an email asking one question or another about their specific topic and their paper. And my response has been, hey, I don't know anything about the topic that you've chosen to write about. I can't possibly know all that. I would like to, but there's not enough time in my lifetime to learn all those different things that interest you. And B, there is not only the science of econometrics, which is proving the Gauss-Markov theorem, or proving that the error covariance matrix is not scalar diagonal and they're the better estimator than just the squares, and so on and so forth. That's the science part. The art part is what specific functional form am I supposed to use? Among my menu of independent variables, which ones should go on in my model? Well, I don't know. Your paper. I couldn't possibly tell you. If you look at articles in the professional journals, you will see in most empirical papers that they don't just report one regression result. They report the different permutations and combinations that they tried. So there's a whole table of results. And every row in the table, depending on the orientation of the table, if you have the variable names in the columns, and then you have a bunch of rows, there may be some blanks in different columns of the different rows, because in one case you included a different measure of capital stock, and in the other equation you excluded it, and so on and so forth. Somebody who asked me about this said, in my paper, I have several different measures of some attribute of the primary sampling unit, which happen to be communities. And so I can measure the financial health of the community several different ways. Which one should I pick? And I said, well, I don't know. And the problem was that the individual had, say, the financial health of the community, he had several different ways of measuring another dimension of the community, and several different ways of measuring a third dimension of the community. But not too many observations. So you couldn't include all those right-hand side variables and get anything meaningful out. And she was smart enough to know that the three different measures of financial health of the community were very highly correlated. So part of the art of econometrics is knowing what to do at that point. At that point, we learn about principal components. So that was my recommendation. So I know the science part. The science part is that if you have multiple measures of the same thing, you can get an aggregate measure of the three of them, and then have only one explanatory variable in your model. You construct a new synthetic variable out of the original three that explains all three of them in a good fashion. So there's the art and then there's the science. You guys are responsible for the art in your paper, and I'm trying to teach you some of the science. The question was, what do I do about it? If I have a cross-section study, what do I do about it? How do I know how to deal with the heteroscedasticity? Well, part of that is experience. Having read the professional literature in whatever your your discipline is, and come across places where other writers or researchers have encountered similar kinds of problems.